Welcome back, class. So, this is the lecture number 11 and one of the most important lecture because here we are going to discuss about the addition, elimination, and elimination addition reaction. Okay, this is as per your syllabus, this is given in the syllabus. So, first we will talk about the addition elimination. That means both reaction. We had already discussed about the elimination reaction, we had discussed about the addition reaction, but this is a combo. Okay, addition elimination reaction, and another name of this reaction is called bimolecular displacement. It follow bimolecular displacement mechanism. Well, it is a very simple one because we had already discussed a little bit things about this reaction in our previous video of a nucleophilic substitution reaction, that in the presence of uh, electron withdrawing group the reactivity of chlorobenzenes or aryl halides enhance. Okay, so this mechanism is based on that phenomena actually. So this is called also addition elimination reaction, and it is a two step process. So the first step is what, in the first step, a take of nucleophile upon the ring to form carbanion. A take of nucleophile on the ring to form carboanion. Point to be noted. Carboanion. Okay. So let's see that what is the uh, process involved here. So this is HO negative. HO negative is what is, this is the nucleophile, and this nucleophile will attack on the ring chlorobenzene. Okay, so what will happen, this is a slow step, this is a slow step, and also the RDS, redetermining. So here what we'll get, we'll get Cl and OH, and a negative charge will generate here. Okay, along with the hydrogen. So this is what addition, this is what addition. Here the carbanion is formed, this is carbanion. Okay, so this is what the addition reaction, and this carbanion will be what, it will be resonance stabilized, it will be resonance stabilized. So I think there is no need to go for that. I'll just quickly I will go for this, that what will happen. Here is the Cl and then the OH, and this is the negative charge and hydrogen. So this negative charge will goes to this side, this moves to this side. So here is the negative charge, pi and pi, Cl OH, then the hydrogen comes to this side, and then this will goes to this side, this will move. So this is the resonating structure of what, of carbanion. Okay, and ultimately we will get the high resonating structure in this pattern. Negative charge Cl and OH. So this is the what? Addition reaction. And then, as I told you, the presence of electron withdrawing group, okay, the presence of electron withdrawing group enhance the stability. Okay, so any group which withdraw electron, it will stabilize the carbanion. Presence of EWG electron withdrawing group, that means we are talking about NO2 CN CHO. What they will do, they will stabilize the carbanion. Okay, and on the other hand, the electron releasing group, presence of electron donating group EDG, will what the electron will donating, that NH2 OH and R. Okay, so this will be what? This will be destabilize the carbanion. So we need to enhance the reactivity, so we need what? We need electron withdrawing group. So electron withdrawing group, if we take the example of electron withdrawing group, then what will happen here? HO negative, and this is the Cl, we all know that, which this we had already discussed now. So I think no need to explain it, but still let's go for that. So this is a slow step. What will happen? This will go to this side and this will move to this side. And now the resonating structure. So here I am drawing the resonating structure, the Cl and OH. This is the negative charge, and NO2. Then the second structure, Cl and OH. This negative charge will go to this side and this will move to this side. Okay, so here is the negative charge and N, and this we had already done in our previous video, but still need to discuss here. Whenever there is addition elimination reaction mechanism, you have to follow this mechanism. Okay, now this negative charge will move to this. So this is what the difference, because this presence of NO2 will certainly extend additional stability. This will give a additional stability. Okay, so what will happen in this case? In this case we have ClOH pi, and this is the double bond NO negative, and this is the positive charge. Okay, N is positive charge. And in the next stage what will happen? Again this will go to this side, this will move to this side, and this electron will shift to this. So ultimately this will give you an additional stability. Okay, negative, as you can see that here we have first, second, third and fourth structure. In this case we have first, second and third structure. So higher the number of resonating structure, higher will be the stability. So NO2 presence will certainly enhance the reactivity of this chlorobenzene. So this is what the difference of addition reaction. And then in the second step second step what will happen? Second step is what? First step is the attack of a nucleophile on the ring, okay, to form a carbon ion. And second step is the removal of halide ion from carbon ion to give the product. So second step is what? Removal of halide ion from carbo anion to give the product, to give. Okay, so this is the second step, that is the elimination step. So we will write that step here. So in that step what will happen? This is the NO2. Point to be noted, without presence of NO2 this will not possible. Okay, so you have to go for the presence of NO2. So this is the negative charge. Okay, this is the final. Okay, and then, and this is what? This is the fast step, because here we are eliminating something. Okay, so this will goes to this side, and certainly this halide ion will be removed. So we'll get OH Cl negative with NO2. So this is what? The elimination, and this is the complete mechanism. So the first step is the attack of nucleophile on the ring to form carbon ion, and in the second step removal of halide ion from carbon ion to give the product. This is the product. That is why it is an addition elimination mechanism, and this is also called bimolecular displacement. Okay, this is a bimolecular displacement because there is a displacement by two step. Okay, it is a two-step process, so it is a bimolecular. Now we'll talk about the another type of mechanism, and that is called elimination addition. Elimination, and that is again very important, because addition elimination you have already studied in the previous video, because we there I'll discuss the mechanism. But next is elimination addition reaction. Okay, elimination addition reaction, this is the page number 2. And another name of this reaction is called benzine intermediate. This is very new for you. Benzine intermediate. That means here the intermediate which is formed, that would be benzine. So first is to understand what is this benzine. Nothing to worry, we all know that ion is what? YNE. Ion is what? Ion is what? Triple bond. Ion means triple bond. Alkane, alkene, alkyne. So benzene means the benzene which contain a triple bond. That means something like this. This is a regular structure of benzene, and if any of the pi electron has contained another pi, so this is the benzene. Okay, triple bond. So let's talk about the mechanism here. Well, we all know that in the chlorobenzene reactivity is very less and certain electron withdrawing group is required. But this mechanism allows you to go for the reaction of chlorobenzene without presence of any electron withdrawing group. Okay, so what we can say that nucleophilic nucleophilic substitution occurs even in absence of EWG electron withdrawing group. It can occur also by the treatment of aryl halide with a very strong base, very strong base. So let's go for the reaction. So this is a chlorobenzene, and in with strong base, so NaNH2 sodium amide is a strong base in presence of liquid ammonia NH3, and NH2 in presence of NH3 will give you an aniline. Okay, this is what aniline. So there is no electron withdrawing group, but still the reaction is possible. So this is a type of elimination addition reaction. So let's talk about the mechanism. Well, this reaction is not a simple displacement reaction. You cannot say that NH2 is replacing Cl, and no, it's not like that. It involves again two step. Okay, again it is a bimolecular reaction. It involves two step. So let's start with the first step. So the first step in the first step, what will happen? The first step is the elimination stage. Don't see that we are discussing elimination addition, so of course the first step will be elimination, but how it is possible, let's see that. In this case, what will happen here? We have Cl, and then a strong base NH2. So NH2 is a lone pair here and negative charges here. This is, you should understand that what is the meaning. Nitrogen is always contain a lone pair, and if you are removing one of the sodium, then this will give a negative charge to this side. Okay, and this hydrogen, there is a hydrogen, everywhere is a hydrogen. So this strong base will abstract a hydrogen, because this is an acidic hydrogen, so this will abstract. So what will happen here? We will get a negative charge here, because this is a negative charge, and this will convert it into NH3. Okay, let's put this Cl here, so you will get a proper connection. Okay, so this is what this is. In the first stage, what happened? Elimination is occur. So this first step is what? Elimination, because the ammonia molecule is eliminated in the very first stage. Elimination. Okay, and as I told you, this is a benzine intermediate, so still we have no intermediate. So what will happen here? here this is a negative charge, this is a pi bond, this is, and this is the Cl molecule. So this electron will goes to this side, and certainly this will is release chloride ion. Okay, so this will get you triple bond, chloride ion will be removed, and this is called benzene. This is benzene with a triple bond. IYN is what? Triple bond. Then the second step involved, the second step, and second step is what? The addition. As benzene intermediate, this benzene intermediate is highly unstable. This is highly unstable, so it will be very reactive. Okay, now what will happen in this case? In the second case, the second step, where we'll get the benzene intermediate, that is a triple bond, and now we have a liquid ammonia also, because we know that there is a liquid ammonia. So the role of liquid ammonia is here, NH2 negative. Okay, so this will attack to this pi electron, and this will give you a negative charge here. So what is the, here we have a pi bond, because this pi electron is moving, so here a negative charge, and this is like this, and NH2. And then in the second stage, NH2, a negative charge, plus now the ammonia, this ammonia will again react, so this will give you what? NH2. So this will give you a negative charge again here. This is explained by one of the book which I gone through, but I don't think that it is an appropriate. So we can take another way to discuss this addition reaction. Although this is correct because it is given in one of the book, so you can go for that, and it is. But for in my concern, I'm not find this is appropriate. So I'll take another way to discuss this. So what we will do that in the second stage of addition, as we have two way for the addition, so we'll follow the path A or path first. In that case, as we have benzene intermediate now, okay, we have benzene intermediate. So let's talk about this benzene intermediate. So this is a benzene intermediate, and the other, and here the attacking reagent is now NH3 ammonia. So this ammonia can attack from two side. If this if we asterisk mark this one, so it can attack from this side also, and it can attack from this side also. So what happened in these two side of attack. If this ammonia is attacked to this side, what will happen? This pi electron will go to this side. Okay, so let's go for this. Now this is a negative charge because this pi electron is moving here, and here is pi, and now the nitrogen, NH, H, and ammonia, and this is a positive charge. Then this negative charge will abstract this hydrogen. This is called proton transfer. Okay, this will abstract this hydrogen, and this will certainly neutralize this nitrogen. So what we'll get? We'll get hydrogen here. This side will get hydrogen, and this side will get NH2. So this is one way to discuss, and I think this is proper, the correct way. Now we'll go for the second path, that is path second. So in this concern, in this way, what will happen? We will have benzine intermediate. Now I'm marking this carbon. Okay, so NH3 will attack to this side, so pi electron will go to this side. Okay, and as the pi electron will go to this side, here what we'll get? We'll get a negative charge to this side, pi electron, and of course the attachment of nitrogen NH3 will be like this with a positive charge. Again, this is will be what? Proton transfer. This is called proton transfer. So this proton will be transferred, and this will give you another. Here hydrogen will be attached. Here in this side hydrogen will be attached, and this side NH2 will be attached. So I think this is the correct way to discuss the second stage, and that is the addition. Although this one is also correct, but somewhere I'm not saying that it is totally wrong, but somewhere I think it is not the good idea to go for this, to go to this mechanism, but this is correct. The addition stage can follow two paths. This is the first path by attacking of this side of carbon, and this is the second path by attacking of this side of carbon. Okay, so I think this is all about from this lecture. One of the very important lecture, you should know that the importance of this lecture. Addition, elimination, and elimination addition. This is one of the important lecture to discuss. Please go through this video, and if you have any query or any doubt or anything you want to discuss with this lecture, you can simply send me in the comment box. I will definitely answer that. Okay, so we will complete this video with one of the question. Okay, so this is the page number 3rd. So let's talk about the question. What is this? Question is write the various isomer of C3H7Cl containing benzene ring. So this is a hint for you. That means you have to write the isomer which contain benzene ring. Okay. And which of these has weakest CCl bond? Which of these has, this is additional question, weakest CCl bond? So this is the question of this video, and I hope you'll find this video answer of this question. One more question I'll put for you, because this is a very simple question. Question number 2, that the para isomer of dichlorobenzene dichlorobenzene the para isomer of dichlorobenzene has highest melting point, not highest, sorry, higher higher melting point than ortho and meta isomer. So you have to go for the answer of these two. I hope you will find that. Please write your answer in the comment box, or you can WhatsApp it to my WhatsApp number, and give your suggestion, your valuable feedback, your comments, so that we can improve next time. Thank you so much. Thank you so much for your watching. Well, let me correct this question. Write the various isomer of C7H7Cl. Okay, this is the correct C7H7Cl. Containing benzene ring, and which of these has weakest CCl bond? So this is the correction, and this is the correct one. Para-isomer of dichlorobenzene has higher melting point than ortho and meta. Explain. So this is the only correction.